I can just ask.
Sir, I have a question.
Yeah.
Sir, last class or lecture 6 অ্যাঙ্গুলার মোমেন্টামের সাথে যে কমিউটেশন রিলেশন গুলো, যে মোমেন্টাম অপারেটর এবং হচ্ছে পজিশন অপারেটর যে কমিউট করে না, মানে আপনি কি এটা কি ওভারঅল ভেক্টর ভাবে বলছেন নাকি জাস্ট হচ্ছে কম্পোনেন্ট? ফর এক্সাম্পল Lx এর সাথে Ax তো কমিউট করে।
Both. All right. So your question is, okay, suppose we have the orbital angular momentum operator L, and then I claim that this is, they don't commute. Now, what does this equation mean? What this equation means is, sorry, they don't commute. What this equation means that if you take any component of L and any component of P, then in general, it's not zero. Okay, that's what it means. So you have to, of course, calculate this too. So L is, as you know, Li is given by epsilon ijk. We can divide it by h bar, but we are taking h bar to be 1, so this is just 1. Then this is going to be xj pk, right? These are all operators. So now if I take Li and say PL, I'm taking L here because I'm going to use the index J as a dummy index to be summed over. And if that is equal to, that is equal to, well, it's, the first thing is epsilon ijk xj pk. And this is PL, right? And now we know that if I have two operators, A times B, and if you take the commutator with C, then I can write it as ABC minus CAB. And then what I can do is that I can also say, okay, what if I add this, subtract this term, which is, say, ACB, then we have to add the same term, ACB, right? And then minus CAB, which is this term. And then we can write this as A times commutator of B and C plus commutator of A and C times B, right? So this is basically a way of breaking up this product of commutators, product of operators in a commutator as sum of commutators, okay? So now we use this in this, equation, then this right-hand side, then LIPL will become, well, we can factor out the epsilon because that's just, that's not an operator, those are just a set of numbers. And then what we can do is that we can say XJ, and then it's going to be PK commutator with PL. And then there'll be another term which will also be epsilon. Okay. So there'll also be another term. Let me just make sure. Epsilon ijk, and then it'll be xj commutator with PL, and then there'll be PK. But we know that the different components of the linear momentum, they commute with each other. So this is going to be 0. So the first term is going to be 0. The second term, we know what this is. This is epsilon ijk, I times h bar delta JL pk. But of course, we are taking h to be 1, so I'm just going to set that to equal to 1. So then what we have is I epsilon ijk delta JLPK. Now we can do the sum. So J is repeated index. That means it's a summed over index using the Einstein convention. So that means that there's a sum over J and there's also a sum over K because that's also a repeated index. So we can do. I'm not gonna I'm going to use a Einstein convention, so I'm not going to write that anymore. So now we can sum over J and replace wherever J by L. So I get epsilon I LK, then PK. So this is going to be the result of the commutator of LIPL. As you can see, on the right-hand side, K is summed over, and therefore it's a dummy index, which is not present in the left side. So now if I say, okay, I take Li and PL, so I'm summing over L now, okay? Then what is this? This is going to be given by PL, LIPL plus LIPL times PL. I'm using again this same, this identity. But now I can use whatever I worked out here, which is going to give me PLI epsilon I L K PK, and the second term is going to give me I epsilon I L K PK PL. So now I see that I've got I epsilon I. This I and this I are of course different. This is just the imaginary unit, and this is an index. And then we get PL, PK, and this term is the same, so I can just multiply it. Now see that here, this is antisymmetric with respect to L and K, but this thing is symmetric with respect to L and K, and we are summing over L and K. So you can verify that when we sum over an antisymmetric object, so if LA is an antisymmetric tensor in L and K, and S is a symmetric tensor in L and K, then this is 0. And therefore, this is 0. And thus, we see that although LI PL is non-zero, LI P squared is 0, where P squared means P1 squared plus P2 squared plus P3 squared. Okay? Does that make sense?
Yes, sir.
Any other question? I hope all of you know how to show this, because if you don't, you need to go and see this. Whenever you contract all the indices, or the indices of a symmetric tensor with an antisymmetric tensor in general, that is 0. Okay, so this is like a few lines of algebra, but you need to do this, and this is a result that one uses a lot. Okay, any other questions?
No, sir.